In this video, you will learn how to balance a redox reaction by oxidation number method in an acidic medium. So let's start. So I have taken a redox reaction, that is MnO2 plus Cl minus giving Mn plus Cl2. So as usual, the first step is we have to calculate the oxidation number. We know that oxygen has been assigned the oxidation number of -2, and the charged species has oxidation number equal to its own charge, and the free molecules or atoms, they have zero charge or neutral, no charge, zero, that is their oxidation number is zero. It's not charge, it's zero. Its oxidation number is 0. So let's calculate the oxidation number of manganese. Let us suppose that its oxidation number is X. So plus, there are 2 oxygen atom into -2. This is as a whole, we'll have to put equal to 0. So X minus 4 is equal to 0. So X is equal to plus 4. That means the oxidation of number of manganese in MnO2 is plus 4. Now see Cl minus, that is it is an ion, so oxidation number is equal to its charge, that is -1. Mn is a free atom, so its oxidation number is 0, and Cl2, that is a free molecule, its oxidation number is also 0. So we have calculated the oxidation number. Now the next step is to find out which species is undergoing oxidation and which one is undergoing reduction. How can we do that? We can do that or find that by looking into the change in oxidation number. So see here, MnO2 after reaction, what happens? The oxidation number decreases from +4 to 0. So decrease in oxidation number means it is undergoing reduction. So this is reduction. And in case of Cl minus, let us see here, Cl, you see here, -1 has become 0. So there is increase in oxidation number. So we can say this is undergoing oxidation. So we have checked. Now in the next step, what we have to do? We have to, again we will write this equation, plus Cl2, and C the elements that are undergoing change in oxidation number, are they balanced on both the sides of the equation or not? So let us check with manganese. One manganese on left hand side, another on right, so both are equal, no need to change, no need to add any coefficient here. Now let's come to Cl minus. See here, there is 1 Cl, but here there are 2 Cl, so we have to balance this, so it becomes 2. Okay, now after doing so, we have to see what is the decrease and increase. So see here, manganese from +4 to 0, so there is decrease by +4 unit. And in case of Cl minus, what do we see? We see that there is increase of -1 to 0. There are 2 Cl, so -2 becomes 0, that is -1 0. The decrease, or sorry, this is oxidation means it's increase. The increase is by 2 units. Okay, now better we write 4 to make it easier. Next step here, we have to equalize these two numbers, that is 4 and 2. How can we equalize 4 and 2? That means what we are seeing is that we have to make this 2 unit into 4. So 2 can become 4 if we multiply this with 2, then it will become 4. So that means what? We have to multiply this species, that is Cl minus and Cl2 by 2, so that the change in oxidation number gets equalized. There are already 2 chlorine, so 2 into 2 becomes 4. This Mn we have to leave it untouched, and this will become 2Cl2. Okay, keep on writing the oxidation number at the same time. So this is 0, 0. Next, what we have to do, we have to balance the oxygen atom by adding water molecules. So on the left hand side we are seeing that there are 2 water molecules but there is no oxygen, so we have to balance it by adding 2 water, 2H2O, that is 2H2O. Now after doing this we see that there is no hydrogen on the left hand side, so we have to balance this by adding H plus ion, because this equation is for acidic medium. So how many hydrogen atoms are there? 4. So we will write MnO2 plus 4Cl minus plus 4H plus gives Mn plus 2Cl2 plus 2H2O. So this is the final equation, but we have to check that whether it is balanced or not. So let us see here. See, Mn in this side 1, in this side also Mn is equal to 1. Oxygen, there are 2 oxygen. On the right hand side there are 2 oxygen. Let's check chlorine. There are 4. Here also chlorine, 2 into 2, 4. Now hydrogen, there are 4. Here also 2 into 2, so hydrogen is 4. Now finally we have to balance, see whether the charge is balanced or not. It has no charge. Now minus 4 plus 4, minus 4 plus 4, so charge on this side is 0, and on this right hand side you can see there are no species which is carrying charge. So here also there is no charge. So that means this equation is correct and it has been balanced properly. So in this way you have to balance an redox reaction by oxidation number method in acidic medium. What are the steps? First step, find out the oxidation number. Second step, find out which species is undergoing oxidation and reduction. Then you have to equalize the change in oxidation number by multiplying with suitable coefficient. After that you have to balance the oxygen atom by adding water molecules, and finally you have to balance hydrogen atoms by adding H plus ion because it is in acidic medium, and then calculate, see whether the whole equation is balanced or not. So in this way we can balance the redox reaction. So let's solve another question on the same topic. I have taken an equation that is ClO3 minus aqueous plus I minus giving us I2 plus Cl minus. This equation we are also going to balance in acidic medium by oxidation number method. So let's start. The first step, as usual, we have to calculate the oxidation number. You know that oxygen is assigned an oxidation number of -2. So there are 3 oxygen atoms, so 3 multiplied by -2 is -6. We assume the oxidation number of chlorine to be x, so x minus 6 equal to -1, that is x is equal to -1 plus 6, that is plus 5. So oxidation number of chlorine is plus 5 here. Now iodine, iodide rather, it's a charged species here, its oxidation number will be equal to the charge, that is -1. Let's come to iodine molecule. It's a free species, so I2, obviously its charge, a free molecule, so its oxidation number, not charge, will be 0. Come to Cl minus, it's a charged species, its oxidation number will be equal to -1. Now we can see here oxidation number of chlorine has decreased from +5 to -1. That means this is undergoing reduction, and the oxidation number of iodine has increased from -1 to 0. That means it is undergoing oxidation. So ClO3 minus undergoing reduction, I minus undergoing oxidation. Now we have to, what we have to do, we have to check those species like that is ClO3 minus and I minus, in them where the element which is undergoing change in oxidation number, the number of atoms of them, are they equal on both sides or not. So let's check with chlorine. Here there is only one chlorine, and this side also there is one chlorine, so it is balanced. We are not required to do anything with that. Next, check iodide ion. See, here is one iodine, but there are two iodines, so we have to balance this. We will write 2 here. So this step is done. Next step, we have to check what is the decrease and increase in oxidation number. So let's start with this one, chlorine. See, oxidation number of chlorine decreases from +5 to -1. So how many units? From +5, that is +4, +3, +2, +1, 0 and -1. So 6 units. So this is decrease by 6 units. Now let's check this one, iodine. See here, there is increase in oxidation number of 1 unit, but there are 2 units, so we have to multiply the 1 unit with 2. So 2 into 1, so increase by 2 units. So we have checked, we have found out. Next step is that we have to balance this change in oxidation number. So here this number is 6, but here the number is 2. How can we balance them? We can balance them by multiplying 6 with 1, which will be equal to 6, and multiplying 2 with 3, that is equal to will be 6, and they will be balanced. So this means what? We will multiply this species Cl minus ClO3 minus and Cl minus with 1. We are not required to write that 1. And iodine, this species and this one, we have to multiply with this number, that is 3. So let's do that. 3 minus aqueous plus, so when we multiply 2I minus into 3, so 2 into 3, 6I minus. Again here to write 3 and plus Cl minus aqueous. So we are done with this step. Next step, we have to balance oxygen atoms by adding required number of water molecules on the side deficient in it. So we check, there are 3 oxygen atoms on the left hand side, but on the right hand side there are no oxygen atoms. That means this side is deficient in oxygen. So we have to balance that by adding 3 water molecules, because in 3 water molecules there will be 3 oxygen atoms. So simply we will write it here, 3 water. Now the next step, this equation is in acidic medium, okay? So we have to add H plus ion in order to balance the hydrogen atoms. So let's do it. ClO3 minus plus 6I minus, giving us 3I2. Let's leave some space here because we have to add hydrogen. I told you, so there are how many hydrogen? 3 2s are 6, so simply we can write here 6H plus, and then same it is 3 iodine plus Cl minus aqueous and plus 3 water. So this is the balanced redox reaction by oxidation number method in acidic medium. Now we have to check, verify whether it is correct or not. So let's count the number of atom. Here chlorine is equal to 1. Here also chlorine is equal to 1. Oxygen, how many oxygen? Here 3. Here you see oxygen is 3. Now iodine, 6 iodine, 3 2s are 6 iodine, it's balanced. Hydrogen, 6 hydrogen and 3 2s are 6 hydrogen. So all the atoms are balanced. The final check that we have to see is whether the charges are balanced or not. See, let us see the charge on this side. -1, 6 into -1, -6, plus 6 into +1, +6. minus 6 plus 6 cancel, so the charge on the left hand side is minus 1. Let's see the charge on the right hand side. There is no charge here, no charge here, only one minus charge. So we see that the charge on left hand side as well as on the right hand side are balanced. So that means we have balanced this redox reaction in acidic medium by oxidation number correctly. So this is the way we should balance. So practice more and more such equation and go through this video more.